For our last topic of the day, section 6, first I want to recall the perfect square trinomial and the difference of squares. So what is the perfect square trinomial? It's a plus or minus b quantity squared. And that is equal to a squared plus or minus 2ab plus b squared. How do you know if there's a plus or the minus? Since so plus correlates with plus and minus correlates with the minus. Right? And then difference of squares, if you multiply the two conjugates, you get a squared minus b squared. So let's do a couple of examples. So the directions say to multiply and simplify. Oh my goodness. So, oh my gosh. 1 second, guys. Finally. Alrighty. Now let's get started with our examples. So example 1, we want to do the square root of x plus square root of 3 quantity squared. Right? So I'm going to use the perfect square trinomial, right? So what in our case, a is the square root of x, b is the square root of 3. Right? And then what is 2ab? 2ab would be 2 times, getting ahead of myself. Let's just apply the formula and we'll talk about it. Right? So what do I know about the perfect square trinomial? I know that equals to a squared plus, since there's a plus here, it's going to be plus 2ab plus b squared. So I'm going to take the square root of x and I'm going to square it, plus 2 and then a, b plus b squared. So the square root of 3 squared. Right? So the square root of x squared, what is that? That would be x to the 1/2 squared, right? So if you want, so this is, so x, the square root of x squared, it was like when we talked about the square root of 3 times the square root of 3, this is square root of x times square root of x. Right? And what is that? That is just x. For the 2 times the square root of x times square root of 3, the square root of x can't be simplified anymore, and neither can the square root of 3. But I'm still going to apply the multiplication property, and I'm going to combine them since they have the same index. So this is the square root of 3x. And then for the square root of 3 squared, what is that? That is 3. Right? And this is our answer. If you're not comfortable with the perfect square trinomial, I highly recommend it. I believe that it will make your life a lot easier. But if not, let's do example 1 again, but the little longer way. So if I have the same problem, quantity squared, what is that? When you square it, it is the square root of x plus the square root of 3, square root of x plus square root of 3. Right, and we're going to FOIL. So same process, the square root of x times square root of x plus the square root of x, square root of x times the square root of 3. So I did this, then this, and then plus square root of 3 square root of x, and lastly square root of 3 times square root of 3. Right, as established, so this is x, and then this becomes square root of 3x. This is square root of 3x. And this is 9. Or, not 9. Oh, my goodness. This is 3. Right? So we're not quite done because since these have the same radicands and they both have the same index, what does that mean? We can add them. So let's do it. So what is the coefficient in the front of here? If there's no number, this is 1. Right? So what is 1 square root of 3x plus 1 square root of 3x? That gives us 2 square root of 3x plus 3. Right? So if done correctly, we will get the same answer as if we do this as opposed to the perfect square trinomial. So as you can see, there's a lot more steps to it. For this next example, we still want to multiply and simplify. So I'm looking at this, and I notice that the first terms of each, so for each factor, the first terms are the square root of x, and then the second terms are 3 square root of 3. And then they're both differed by a plus and a minus. What does that mean? This means that these two are conjugates of each other. Since they're conjugates of each other, we can use the difference of squares formula. So what is A? A is the first term of the factors, which is square root of x, and B is 3 square root of 3. And what does the perfect square formula tells us? If we multiply the conjugates, then we'll get a squared minus b squared. So this would be the square root of x, quantity squared, plus 3 square root of 3, quantity squared. Right? Square root of x squared, that is x. And then for 3 square root of 3, quantity squared, if you, in the properties, I think from a couple of days ago, I forgot what the property is called, but this, it would become 3 squared times the square root of 3 squared. Right? And this is x plus 9 times 3, so then we get x plus 27. Right? So if you don't believe me that you can just put the square root on each term, let's talk about it a little bit more. So if I have, so let's do a different color to know that we're not talking about the example, or like this, we're done with this example. If I have 3 square root of 3, quantity squared, when I have a square, what does that mean? This is 3 square root of 3 times 3 square root of 3, right? And then I'm going to take the terms that don't have a radical and the terms that do have radicals. So this is 3 times 3 times square root of 3 times square root of 3. 3 times 3 is 9. The square root of 3 times the square root of 3. If I use the multiplication property, this becomes the square root of 9. What is the square root of 9? It is 3, because 3 squared is 9, and then 27. Right? So this is how we get that. But yeah, this is the exact same as saying 3 squared times the square root of 3 squared. And that is it for our topics today. If you want, the next video, I'm going to do this one problem. I notice students usually have a hard time, and I don't blame them because it's long and can be challenging. So if you want to listen to that, watch the next video.